Okay, thank you. Good afternoon. The GLASS products stand for Global Land Service Satellite Products. And first, I would like to thank you those for contributing to this project and the funding support made from the Chinese Ministry of Science and Technology. After a brief overview of the GLASS products, I'm going to provide some a little bit more details on individual products. And so far, we have 5 products, and the first 3 products, the similar spatial temporal resolution to existing products, but it covers much longer temporal coverage from 1981 to now. And we also have 2 radiation products, but only for 3 years. And spatial resolution 5 kilometers, and temporal resolution every 3 hours. And the data products can be downloaded at data center at Beijing Normal University, but also at the famous Global Land Cover Facility at the University of Maryland. And the overview of those products has been described in the paper published a couple of months ago in the International Journal of Digital Earth. And more details of the algorithms, validation resource, and preliminary analysis are in the book just published a couple of months ago by Springer. The GLASS algorithms versus other existing algorithms are described in the textbook, Advanced Remote Sensing, published about 1 year ago by Academic Press. So if you miss any points from my presentation, certainly you can check those documentations. The first product, Global Land Service Albedo, and we have so many different products so far. And GLASS Albedo very similar to most of them, but the only difference here is the much longer temporal coverage, and that is critical for long-term environmental changing studies. And the algorithm and some validation results have been published. And here I do want to point out, we're using both AVHR data for the first 20 years. And then after 2000, we're using MODIS data. For MODIS data, we're using 2 algorithms and generating 2 intermediate products, and then using data fusion approach to generate the final product. So as far as I can tell, that probably is the first satellite land product generated based on integration of multiple algorithms. And this is the animation of the global albedo. You probably have saw it in some other places. And if we look at the global average, it's quite stable, but it has seasonal variations. In the winter, particularly, we see the snow coverage, albedo getting bigger, and then in the summer, albedo getting smaller. And if you look at the anomaly, there are some trends. There are no overall trend globally, but you can see some increase here, some decrease here. It really depends on what times period you look at. This is the global average. If we look at the details, and actually these are a lot of details missing here. This is the latitude, and this is the past 1 decade. And if we look at, this is the anomaly. There are a lot of information here. For example, around 2005, there was a significant albedo increase in the south hemisphere here. That probably has something to do with the severe rainfall in the south hemisphere. And if you also look at the high latitude in the north hemisphere, the decrease in albedo, that probably has something to do with global warming, resulting in the reduction of snow coverage. If we look at the general circulation models using for the IPCC, the 5th assessment report, and the different GC models produce different albedo values. And obviously the differences are very significant. And this is the global average. So if you look at the details at the specific time and location, the difference is even much larger. Particularly if we compare to the GLASS product here. Most of the models looks like underestimate service albedo. So that satellite product is very important for calibrating or validating model simulations. Another example is surface albedo changes over Greenland in the past 30 years. This is the first 20 years. The albedo change is quite small. And then in the last decade, the albedo change is quite significant. This is the summer over Greenland in July, pretty much. Particularly in the low elevation region here. The albedo decreased very significantly. This is the surface elevation. So it's the high elevation, this is the low elevation. So that albedo reduction, the decrease, probably has something to do with the global warming, the temperature increase. And this statistical test telling us from 1981 to 2000, the albedo changing not statistically significant. But in the last decade or so, and the albedo decrease so significant. If we look at the average albedo over Greenland, and this is the solid line here, it's interesting to see in the first about 20 years, the relatively stable, although fluctuating a little bit. But from 1996 or so, there's significant albedo decrease. Here, what I try to show is, if we only using albedo in the past 10 years, the trend we got cannot represent the overall trend. That could result in a wrong conclusion. And so long-term albedo product is very important. Another interesting thing is the reason albedo decrease is highly related to the North Analytical Oscillation Index. So albedo changes can reflect the big atmosphere circulation to some degree. The second product is Lee Field Index. And the similar temporal spatial resolution and also covers longer temporal period. So what we did is based on the neural network. Well, a lot of people are using neural network for producing satellite products. So what we did is a little bit different. We're using 1 year MODIS data or AVHR data, input it into the neural network, and produce 1 year EOEI simultaneously. So that way, the generated EOEI is much more stable. And here I just showed you one example. And those are the validation results from the GLASS EOEI in comparison with the MODIS validation and cyclopy validation. And most importantly, GLASS albedo is spatially and temporally continuous, so no data gaps. And then represents the phonology quite well, matches smooth compared to MODIS and cyclopy data here. I just put it from the paper published this month. The third product is surface emissivity product. And we all know that the surface emissivity is very important in calculating surface radiation budget. But if we look at the global circulation models, and most of the models assume constant values, all based on the very simple parameterization. Part of the reasons is that we don't have global emissivity product available at this point. Now, what's the big deal? A few years ago, we carried out a study. Okay, we calculated the broadband albedo from MODIS spectral emissivity, the broadband emissivity from spectral emissivity, the summer and the winter. And then we calculated, we run a couple of atmosphere model with the community Liang model. We keep everything the same. This is the 2 random days. And running the couple model twice. The first running the model using the default emissivity value. The second time we running the model using MODIS emissivity value. The difference very significant. This figure showing the skin temperature, the ear temperature. As you can see, the emissivity can result in the ear temperature as large as 2 degrees. So we keep everything constant except changing surface emissivity. So that demonstrates surface emissivity is very important in global circulation models. So those are the spectral emissivity products available from satellite data. and pretty much they're spectral products. And the series generally a broadband emissivity map, so it doesn't have spatial and temporal the temporal variation. And the glass emissivity has 8 days. It's the broadband product. We have published a bunch of papers on this product. And as you can see, the tremendous amount of variations depends on the season, particularly the changes in vegetation coverage. And we made a comparison. Well, this is the ground validation. And we also made a comparison with the North America emissivity data put together by Simon Hawk Group in NASA JPL. They are putting ester emissivity data over the decade and generate the 2 seasons emissivity maps over North America. And then we still can see, even using 12 plus years ester data, there's still gaps here. And this is the glass emissivity maps. Every 8 days continuously, especially in the temporally. And the difference actually is quite small, very close. So that demonstrates the high quality of glass emissivity product. The last 2 radiation products, one is the shortwave, another is the PAR. Most of the people are using very coarse radiation products like ISCCP data, GV2M series, those pretty much from satellite data, and then also some reanalysis data. They have high temporal resolution, but the spatial resolution is too high, and too coarse for Liang applications. So glass radiation products pretty much 5 kilometers, 3 hours. So why do we need high spatial resolution? Here I put in the WMO requirements for shortwave radiation. The 3 applications here. The worst spatial resolution, that's threshold, from 20 kilometers to 100 kilometers. But the best resolution will be from 1 kilometer to 25 kilometers. So most of those products cannot meet the requirements. So what we did is to combine MODIS with several geostationary satellite data so that we can generate the radiation every 3 hours. Otherwise, we won't be able to do it. And so this is the instantaneous shortwave radiation, indicating sun rising from the east to the west. And then this is the PAR, the monthly PAR average. Of course, we did extensive validation. And here, even we aggregated the same to the same resolution as ISCCP or series. And it's a validation resource here, the statistics from glass radiation plot much better than the other products. So even we have the same spatial resolution, the accuracy is still better. And of course, we have much higher spatial resolution. So what's the big deal? What's the high improvement PAR product? Here just one example. And we're using a radiation efficiency model to calculate the GBP as giving multiple presentations in this meeting. Now we're using 6 different radiation products. This is the glass radiation, ISCCP, Princeton dataset, and those 3 reanalysis dataset. And using the ground measurement to validate the outcome. It turns out glass radiation product produces the best GBP values. So everything is the same except the solar radiation as the input from different sources. So we're using this approach to calculate the GBP map of China in 2008 and 2009. Obviously, you can see different radiation products produce different spatial patterns of GBP. So that demonstrated the importance of using high quality solar radiation data, particularly PAR product. So that was the phase 1 glass products. And we just started a new project, the phase 2 glass products. Eventually we're going to generate 12 products, more service radiation budget components. and also more vegetation parameters, like the flashing of green vegetation coverage in GV2, ET, and so on. And long-term high-quality satellite products are essential in detecting and assessing global environmental changes. And glass products have some unique features and also have been extensively validated. I put in some DVD outside in the conference room, and they're including some papers there and sample data. But also, there's still some brochure outside about the data side, website and other information. That's all I have. Thank you.
Thank you very much. We have time for questions. 1, 2 questions?
Hi, gentlemen. So I think this is really potentially very useful product. I know on the VIDO trend